This video lesson introduces the idea of limiting reactants using a very simple method called the lasso method. For this lesson, you'll need your Unit 3 notes packet open to page 3, your yellow objective packet, and a pencil or a pen. The learning goal here is number 10K, to determine the limiting reactant in a chemical process and solve stoichiometry problems involving limiting reactants. Remember from our class discussion that we have now introduced the terms limiting reactant and excess reactant. We've learned that in a chemical reaction where we have limited quantities of each of the two reactants, one of those reactants is going to run out first, bringing the process to a halt. The limiting reactant is the word that we use for the reactant that runs out first. Because it runs out and brings the process to a stop, the limiting reactant controls the amount of product made, and this is ultimately the reactant we're going to need to use in our stoichiometry calculations. The reactant that you have too much of is called the excess reactant, and this is the one that does not run out. It has absolutely no impact on the amount of product made, and at the end of the reaction, your excess reactant is going to have some left over. Let's start our first limiting reactant problem as a relatively simple problem that we can actually do in a very visual sort of way. I would like to know how many moles of NH3 can be produced from 2 moles of N2 and 10 moles of H2. And we have a balanced equation here that tells me for every 1 mole of N2, I will need 3 moles of H2 to go with it, and I'll be able to produce 2 moles of NH3. This problem we're going to solve in kind of a graphic drawing sort of way. To represent the 2 moles of N2, I'm just going to include a picture here of 2 N2s. And to represent the 10 moles of H2, I'm going to draw 10 H2s. And we'll do those in blue. And just to save some time typing here, copy this and paste that right there. So I now have a representation of 2 moles of N2 and 10 moles of H2. Now I'm going to get a pencil or a pen, and I'm going to start looping together what it takes to make the reaction occur. I know that for this reaction to occur, I need 1 mole of N2 and 3 moles of H2. And out of that, I'm going to be able to produce 2 moles of NH3. So over here, at the end of our lasso, whoops. I'm going to have 2 NH3s. And let's make those green. And now I'm going to do this again. I'll get my pen back, and I'm again going to loop together 1 mole of N2 and 3 moles of H2. And that is again going to make 2 moles of NH3. And then I get my pen and I do it again. Except this time I haven't got any N2. So the process is going to come to a halt at this point in time. I can't do this again because I've run out of N2. Notice then that the answer to my question here is that I can make 4 moles of NH3. After that, I haven't got any nitrogen left, and so the process is going to come to an end. This method gets its name because the little loops that we use to loop up our reactant and the tail we use to show how much product we make, when put all together, look a little bit like a lasso. Also out of this process, I can see that N2 is the limiting reactant, and H2 is the excess reactant. And I can even see that I have 4 moles of H2 left over when the process is complete. This is a relatively simple, very visual way of beginning to understand limiting reactants. In our next video, we'll take this to a slightly more mathematical approach, but this is a great place to start in your understanding. At this point, you should go to your turn problems and do the 3 problems that go with limiting reactants 1, the lasso method.